Hello guys, so here we are. So today we are going to solve Fourier series, okay, Fourier series for discontinuous function like this one, that we have a direct interval between the main interval with this one. So whenever we have this discontinuous function, okay, like this one, f of x is x when x is in between -1 to 0, okay, and and f of x is equal to 2 when x is in between 0 and 1. Okay, what do we have to do in this case? Okay, we know that f of x, it's like Fourier series. Okay, it is nothing more or less than whenever we have a function. Okay, it stays just whenever we have a function, whether it's continuous or discontinuous. Whenever we have any function, so this function can be written in a form of a series. And as we know, series, it is what? It is the sum, okay, of infinite terms of any sequence, okay, just like this one. Okay, this is a series because we have sum of infinite series of infinite terms of a sequence like this one. Okay, sorry. So this is what we have. So the first step to be followed is whenever we have a discontinuous function, first here the limits are taken as per given discontinuous interval. What does it mean? It means that so here we will just draw the limit as it is, okay, in the beginning from -1 to 1. Then when we start solving for this interval, we will split this f of x into x when the limit when the x will be between this limit -1 and 0, and f of x will be 2 when it will be 0 to 1. Okay, this is what does it means. So the period L is taken by comparing the first and the last boundary of both discontinuous interval. So what does it mean? It means that suppose here we have this limit is from -1 to 0, and here it is 0 to -1. We will take the whole limit, okay? The first one, it is this one, and the last one is this one. So we have to compare the first and the last ones, okay? The last interval, this one and this one. And we will compare this one for the Dirichlet limit, okay? Dirichlet condition for all limits in this case. So we will just compare this one. So this one will be C, okay, like this one, like you can see. -1 will be equal to C, and 1 will be equal to C plus 2L. And as you can see here, so -1 equal to C, C is -1, so here you can just put the value of -1, 2L is equal to 1. So C plus 2L is equal to 1, just do this one, okay? And you will find here what is L. L is the period of this function. Now the following step, it is just to find A0, AN, and BN. And this is what we are going to do, okay? Okay, stay with us, life will be good. Okay, okay. So now that we have found that for this, we have just to find what is A0. Okay, A0. What will be A0? Just like this. Okay, I have to find what is A0. So A0 by formula, we have a formula for this one. It is 1 by L integration. Okay. And this will be C plus 2L and C, okay, the limit, general limit of f of x dx. This will be A0. AN will be 1 upon L, okay, integration from C plus 2L and C. And here you get f of x cos of n pi x upon L. Okay, L is the period of the function, dx. And Bn will be 1 upon L integration. And this will be between C plus 2L and here C, f of x, and sinus of n pi x upon L. And here it is also dx. Okay, now that we have found this is the general formula. Now we have to find what is A0. So A0 will be 1. Here we know that what is L? L here is 1. So now in the period, just substitute 1, 1. And here if you put 1, C is minus 1. So, okay, C is minus 1. I'm not just guessing. It's from here, okay? Yeah. C is minus 1. If you put here minus 1, minus 2 times 1, it will be 1. 1 and minus 1. Okay? And here, what will be f of x? F of x, just keep it like this one. And here now, you will just divide this, split this interval, because it is the general limit from 1 to minus 1. But this limit, it is discontinuous. From minus 1 to 0, the function will assume this value. And from 0 to 1, the function will be 2. So let us just split this one. Then this will be 0 from minus 1. The function will be x dx plus, now what will be the next? Integration from 1 to 0 or 0 to 1. It will be 2. The function will be 2. F of x will be 2. Now from here, just find this one. This will be x squared by 2. It's in between 0 to minus 1 plus, okay, here you got 2 outside and it is x. It is in 1 by 0. So just work it out. Just put it here for 0. This will be 0 minus, okay, 0 minus 1 by 2. Okay, 1 by 2. Why positive? Because when you put here minus 1 square, it is 1 positive. So plus, then just put here for 1 and minus 0. So this will be twice, okay, twice 1 minus 0. So then just work it out. You get in 3 by 4. Okay, this is a0. Now as you found a0, we are going to find what is an, bn. Then we can just build up this the function f of x as in a form of a Fourier series like this one. This one. We are just start to find what is bn, what is an. Okay. For second term, what is now an? That's the point. Now, what is an? Okay, how to find an? So an, by this formula, we just substitute this one. It is 1, and here you get 1 minus 1. And here you will be f of x cos of n pi, cos of n pi x by L. What is L? L is 1 here. Just put here 1. Okay, 1 dx. So this will get, okay, for these values now, for the broken intervals that we got, this will be from 0, minus 1 from 0. This will be x. F of x will be x at this time. Then you're going to find cos of n pi x dx. So here, plus integration for the second interval, it's 1 from 0 to minus 1, from 0 to 1, and this interval, the function is 2, and cos, just remain cos, n pi x dx. Now what we have to do is just to find this integration, let us to find just what will be an. So an, okay, an, let me put this one so that this cannot just drop down. An will be what? An will be equal from here. Just find this in this here. Okay. I have already calculated this in this integration here. You have just to do this one, px. Okay. Pick up the polynomial expression is equal to p to x. Then derive till you get a constant number. Okay. It will be 1. Then the second part, that is trigonometric, integrate the second part, n pi x dx. So integrate, how many times do we have to integrate? You have to integrate the number of polynomials that you have here. According to the number of polynomials you have here. You have here 2 polynomials, so integrate twice. So you will get this one. Cosinus integrated, it is sinus. So it's sinus n pi x upon n pi. Then integrate once more. So sinus integrated, it will be minus cosinus n pi x. And this will be n pi square minus. Now just link this and this, and this and this. Okay, do not forget this is minus. So for the first it will be positive. Just multiply this and this and this and this. Okay, just multiply, and here it will be minus, plus, minus. If there were some more terms, you should just play this sign like this one, plus, minus, minus, and so on. Then just link this and this, this will be the result for this integration. Okay, and we will do this. Okay, so now it means that an, okay, we write here, an will be equal to, what is this integration? That's the point. So just see, look at this one. This will be x sinus of n pi x, okay, n pi x upon n pi. Then minus and minus will be plus. Plus this and this will be cos n pi x upon n pi square. Okay, then it is in between 0 to minus 1, plus, now you go for this one. This integration is directly known. Okay, this will be, if it is cos, when I integrate cos, this will be sinus, okay, n pi x upon n pi, and it is in between 1 to 0. So let us work then for this one, for an now. Okay, we will just substitute the values. Okay, we will substitute the values that we got. Okay, values, this one. Okay, let us check for this. Just check in here. Okay, see, when I substitute for x equal to 0, put here x equal to 0, this expression will be 0 because x is 0, 0. And here if you put 0, you get 1. Cos of 0 is 1 upon n pi. Okay, n pi square. Now if you just put here, okay, let me just start write and say telling you and writing also. So for the first expression it will be 0, and for the second expression you get 1 upon n pi square. Okay, 1 upon n pi square, minus, for the second one, when this x is minus 1, put for minus 1 here. So see, when I put here minus 1, it will be sinus of n pi time minus 1. Sinus of this will be sinus of minus n pi. So whenever I have n minus sinus of minus n pi, it will be 0. Why? N is an integer number. So whatever integer number that we put here, like 1, sinus of pi will be 0. Sinus of 2 pi, 0. 3 pi, 0. 4 pi, 0. So this will be 0 directly. Okay, so for the first will be 0. And how about for the second value? So for the second one, put here minus 1, you get cosinus of minus n pi. Now see, cosinus of minus n pi, okay, just let me see, cosinus of minus n pi, it is the same of cosinus of n pi, and it is minus 1 to the power n, okay, minus 1 to the power n, this one. Now just write down there, okay, then it will be plus, okay, plus, okay, minus 1 to the power n upon n pi square, okay. Now that we are done, we have just to do what's the next step. So here you can see the second one, it is plus 2. Just substitute. When this is 1, n pi, sinus of n pi, it was 0. And for 0, it will be 0 also. So for the second step, it will be 0 minus 0. So this will be this one. It means that I'll get an is equal to only this part here. 1 upon n pi square minus, and here this minus and this minus, this will be plus, and this minus will be minus 1 to the power n plus 1. Okay, n pi square, and this way. So from here, just substitute. Okay, just substitute. Suppose here it is a odd number. Okay, they have the same denominator. So when this n got a odd number, when this n is an odd number like 1, okay, this will be 2. 1 plus 1, 2. This will be positive. Then I will get, for odd number, this will be 2 pi n square when n is odd. Okay, when n is odd. Okay, when n is odd. But when this guy is even, this will be minus 1. Minus 1 minus 1, this will be 0. So it will be not, there will be no, how can I say, it will not exist, okay, the series for n even. Okay, for n even it will be 0, the series. Now that we have found what is an, okay, the next point is to find what is bn. So bn, it is the same, 1 upon L integration of c plus 2L, and here c, f of n, okay, f of x, then sinus of n pi x dx upon nl. So just substitute for L. If you substitute for L, what you will get, bn is equal to 1 by 1 integration 1 minus 1, and here f of x, then sinus of n pi x upon L and dx. Okay, now just split it into the intervals that we have. 0, minus 1, the function will be x, and sinus of n pi x dx. Then plus the integration, and it will be from 1 to 0, 0 to 1. So this will be 2 and sinus of n pi x. So dx then. So here we have to do the same exercise, okay? P of x, pick up x, then derive this one, this is the first one, this will be 1. And here just integrate the sinus n pi x, then dx, okay? Integration of cosinus, this will be, of sinus, this will be cosinus, this will be cosinus negative, and n pi x, okay, upon n pi. Then integrate again. So I have to integrate twice because here I have two polynomials. So twice, integrate again, this will be minus. Then you get sinus of n pi x all upon n pi square. Okay, let me just put this button here, n pi square. Now the next step is just to link it up. This will be positive, this will be negative. Then multiply this will be the result for your integration directly. So it means that bn will be equal to, okay, this will be x times this will be minus x cos of n pi x, okay, all upon n pi. Then minus times minus, this will be positive, okay, positive, and you'll get 1, this one, it will change nothing, n pi x upon n pi square, okay, and this is in between 0 and minus 1, plus the second expression here, integration of sinus, this will be 2, it will be cosinus negative, okay, minus cosinus of n pi x, okay, upon n pi. And this n by x is in between what? 1, just in between 1 and 0. So here, bn, substitute for 0, put here 0, it will be 0, put here 0, it will be 0. So for the first expression, I'll get 0 plus 0. And minus, for the second limit, put here minus 1, okay, and put here minus 1. There you get what? If you put here minus 1 and minus will be positive 1. So here you will get positive 1, and here this will be cosine of n minus n pi. So this will be only minus 1 to the power n upon n pi, plus this again. If you put here n equal to minus 1, this will be 0, all of them. So plus 2. Put here for n equal to 1. If you put here, this will be minus 1. This will be 2, okay. 2 to the power, here I get minus 1, this will be minus 1 to the power n upon n pi, okay. minus, okay, this is the minus from the formula, but now here this guy has also minus, and cosinus of 0, this will be 0 and pi. Okay, now we have just to solve this one. So here we know 0, 0, 0. This one, minus and minus, will be what? It will be not be plus. It will be minus 1 times minus 1 to the power n. And this guy will be minus 1. Sorry. Okay, let me just write down this one. I will write down here. Okay, you write down here. So this will be minus 1 to the power n upon n pi. Then here, what will I get? This and this. This is, okay, from here, minus 1, and minus 1 to the power n plus 1. Okay, yes, that is right. Now, from the next, what will I get? Here also, I will get 2 minus 1 to the power n plus 1. I'll get plus 2 minus 1 to the power n plus 1 upon n pi. And for the third term, I will get also here, it will be plus, I'll get plus 2 upon n pi. Okay, as you can see here, this is Bn. Okay, nice. Now that I have found what is Bn, what is An, what is Bn, so I will write down here Bn. So Bn, it is, just look at this. Okay, just look at this. This one will be 3. It will be 3 minus 1 to the power n plus 1 upon n pi plus 2 upon n pi. This is Bn. And what is A0? A0 is 3 by, okay, here we have calculated A0, but actually it's not 3 by 2, 3 by 4. It should be 3 by 2, sorry. Okay, this should be 3 by 2, okay, 3 by 2. Sorry for just this one. Now that we have A0, okay, now that we have A0, Bn, An, we have just to substitute and to find what is our what's the name, the Fourier series for this one. So here we will write this one, f of x will be equal to A0 by 2, A0 by 2 by time An, then it goes from 1 to infinite, cosinus of n pi x, okay, we know here upon L plus Bn, and here the sum between from 1 to infinite of sinus of n pi x, sorry, divided by L. So we have just to substitute, okay? So f of x will be 3 by 2 or divided by 2, okay? Plus An. What is An? We said that there is no An when n is even, okay? So I will write down here. An will be 2 upon n pi square, okay? N goes from 1 to infinite, but only when this n is odd, okay, when this n is odd. And here I will get cos of n pi x because L is equal to 1. Then plus, what is Bn? Bn is over there, so this will be 3 minus 1 to the power n plus 1, okay, plus 2, all of this divided by n pi, okay, this is my Bn. Okay, and here I just have to find out what is sinus of n pi x. Sinus of n pi x. This goes from 1 to infinite. Okay, so in this way you have to write the Fourier series. Okay, so I hope it can be helpful for you. So f of x, let me just do it, the last hint. It will be 3 by 4 plus 2 by pi square, and this one will be infinite from 1, and here I'll get cos of nx, okay, pi, or it can be n pi x and x pi, it's okay, it's a product, so it will be upon n square plus 3 time minus 1 to the power n plus 1 plus 2, okay, all of this divided by pi, then okay, sum from 1 to infinite of sinus of n pi x divided by n. Okay, this is our Fourier series. So thank you very much. See you when I see you.